Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullahi wa barakatuhu.
وعليكم
In the previous discussion, we had taken two populations into our account and we tested the hypothesis for population means. And the basic assumption that we used in that section was known population standard deviation. Known population standard deviation. And in that case, we used Z statistic. So we covered that section and we solved several questions from that section. And now I am confident that the idea would be cleared. Now we want to see the situation when population standard deviations are unknown for both populations under consideration. So in that case, we want to see that whether the population means are equal or not. So in that case, definitely, as previously we had seen that T distribution was there. In all those cases, when population standard deviation was unknown. So basically in chapter 10, we were taking into our account only one population. And for that population, the population standard deviation sigma was unknown and we were using T distribution or T statistic in that case. So now as we are talking about two populations, and if in case of both populations, the population standard deviation is unknown, then we may take help of sample standard deviation S. And definitely in this case, we will use T statistic. So as we are saying that populations are independent and population standard deviations are unknown, uh, so we may use the T statistic, but for this, there is a slight change in the formula. So you may see the formula that we use in this case is this. T is equal to x1 bar minus x2 bar sp square into 1 over n 1 plus 1 over n2 square root. So what are these terms? X1 bar, you are familiar with this term. This is the population. This is the sample mean for first population. X2 is the sample mean for the second sample mean that we have definitely found from sample data, that is for the second population. So is the mean of the second sample. N1 is the number of observations in the first sample. N2 is the number of observations in the second sample. And what is this SP square? SP square is the pooled estimate of the population variance. So basically, we give weight to the variances, or basically these are the S1 square, the sample variance. S2 is the sample variance. This is in case you are considering first population, and this is S2 square for second population. So when you are going to take sample from second population, so this is the sample variance. So when you multiply these terms with the degrees of freedom, and 1 minus 1, this is basically the degree of freedom, and similarly n2 minus 1 degree of freedom for second sample. And so basically you are giving weights. So if you recall the uh, formula that we used in weighted average, so what we do, we give weights to the values. So in this case, we are giving weights to these sample variances and divide it with the total degree of freedom, that is n1 plus n2 minus 2. So as n1 is the sample size for first sample, this is the sample size for second sample. And why you are subtracting 2 from this? Because total samples are 2. Okay, so in this formula will help you in pooling the variances. So basically, we want to have one value, as we are saying that population variances are unknown, but we are saying that they are equal. So we are assuming that as they are equal, so we are able to pool them. Okay, so we wanna pool them to have single value, or you may say that this is the average value, as there are two sample variances. So basically, if you see this formula is basically providing you the average. So basically, you are adding and then dividing with the total number of observations. So in this particular case, you are having the average variance, and that average variance, sample variance, uh, is named as pool variance. Okay, or when you will take the square root of this, definitely that will become the sample standard deviation. So pool sample standard deviation. uh, so you are basically using this value sp square over here in this formula, and the remaining values are same. You are familiar with all these values. So let us solve one example uh, to get further explanation of the idea or the concept. The production manager, this is basically self-review question in your book. If you see, this is the question, self-review 11-1. So you may solve this example on your own. Basically, it is solved over here. You may see this formulae are also there. Everything is there. So this is the question, and I am leaving this question on you. You have to see this question. It is basically completely solved. So you simply have to see that how the writer is solving this question. So let us solve this self-review 11-2. The production manager at Bellevue Steel, a manufacturer of wheelchairs, wants to compare the number of defective wheelchairs produced on the day shift with the number on the afternoon shift. The sample of the production from 6 day shifts and 8 afternoon shifts revealed the following number of defects. So during day shift, when wheelchairs were being produced, 5 defects were there, 8 defects were there, 7. So like this. And in afternoon shift, these are the defects. At the 0.05 significance level, is there a difference in the mean number of defects per shift? So you have to solve this question as it is required in parts. So you will answer the question in parts. Otherwise, if these parts are not there and simply question ends over here, so you can solve it in 6 steps. So let us solve it in 6 steps, and we will have answers for all these questions, in fact, in that case. So how will you start solving this? First of all, there will be step 1. And you know what is step 1? Null and alternate hypothesis. So you have to construct these two hypotheses, H naught and H1. Population means are there. So you will write down mu, 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 and mu. And whether there will be equality sign or inequality sign, for that you have to consider the last statement. Is there a difference in the mean number of defects per shift? So as word difference is there, so this is a hint that equality sign will be there. Is there a difference? So if mu1 is equal to mu2, that means there is no difference. So that will be in the null hypothesis. So equality sign will be here and inequality sign will be here in the alternate hypothesis. Now, to discriminate the day shift from the afternoon shift, you may give subscripts to mu's. So you may write down here mu a, and here this was the afternoon shift, or if you want to write it down as day shift, so you may write down no problem mu d, this is day shift, and mu a afternoon shift. Similarly, day shift and afternoon shift. So now it will be easy for you to take into your account that which sample you are using. Otherwise, you may give mu1, mu2, but D and A will help you in recognizing quickly that which shift is this. Then comes step 2, level of significance or significance level. Level of significance. So in level of significance, you will see that what is the given level of significance. It is 0.05. So you will use this alpha is equal to 0.05. If level of significance is not given in any question, so you may safely use 5% level of significance, that is this 0.05, because normally we use this. Then comes step 3, that is test statistic. So here you have to write down the formula, and before writing down the formula, you have to consider the situation. So you may see that there is no information regarding populations standard deviations. Okay, there is no information regarding standard deviations of the populations. Sigma 1, sigma 2, or sigma D, sigma A, these two are missing. So it means that you will use T statistic. You will use T statistic, not Z. And as there is no information regarding whether the unknown population standard deviations are equal or not, so you will use, it's upon you, but normally we use or consider or assume that the unknown population standard deviations are equal. Okay, it means sigma 1 is equal to sigma 2. We assume this. So if we assume this, then the formula will be this. This will be the T statistic. And if population standard deviations are unknown and unequal, then the formula will take another shape that we will write down in next lecture. Uh, we will basically, in that case, will remain unable to pool. So SP will not be there. In fact, SP square will not be there. And instead of that, we will have the sample variances separately, independently. So we will talk about that later on. But in this particular case, as we are assuming that as there is no uh, description or explanation regarding the population standard deviations, so we have to use T statistic. And as there is no information regarding equal or unequal population standard deviations, so we are going to consider equal population standard deviation. So in that particular case, what will be the T statistic? T statistic will be T is equal to x1 bar. So x1 in this case is, you may write down D minus x2 bar. So that is xa, fine, divide by sp square. This will remain same. 1 over n1. So you may write down 1 over n sub d plus. So as there is n d and n a, so this is the formula, square root. So you may confirm this formula from here. Same formula. SP square 1 over n1 plus 1 over n2. So we are writing down nd and na. So wherever 1 is there, we are writing down d. Wherever 2 is there, we are writing down a, afternoon shift, for our own convenience. So you will stop it over here and you will move to step 4. The step 4 is decision rule. Decision rule. What will be the decision rule? We are considering, we are assuming that the distribution is normal. That the distribution is normal. So therefore, you will draw the normal distribution over here. Sorry. Fine. So now it's upon you. You may write down here two scales, Z and T. Sorry, T or the x1 bar minus x2 bar scale, or straightforwardly you may take this as Z scale, sorry, T scale. So it's upon you. But if you are going to consider this separately, as far as we have already done this, if you are going to consider this as x1 bar minus x2 bar, so you may consider, no problem. Then you would have to draw another scale, that is T. So in this case, it will be like this. So it's upon you. If you want to simply write down T scale, then you may give only one scale, but the concept should be clear that there is this scale there, x1 bar minus x2 bar. So in the center, mu, so definitely in this case, it will be D. This is D and this is A. Day and afternoon. Similarly here, D is equal to mu A. And against this, the value of T is 0. Now you have to put the tails in the distribution. So for that, you have to see the null and alternate hypothesis. So in the null hypothesis, equality sign is there. It means that this is two-tailed distribution. So you have to put two tails, lower tail and upper tail. Now, as it is two-tailed, so you have to use the level of significance as alpha by 2. And here again, alpha by 2. So alpha is 0.5, sorry, 0.05 in this case. So 0.05 divided by 2. The answer is 0.025. Similarly, in this case, 0.025 will be the value for rejection region. So now you have to find out the critical values. I mean, the value that will be at this particular point, at this point, and at this point. So how will you find that? Now you have to use the degree of freedom and the level of significance. So you are considering this as a single tail. So you may use the T table. This is your T table. So if you are using single tail, so you will see this central row, one tail. You will move rightward. This is the value 0.025. And if you are considering only two tails, you are considering two tails, then the level of significance will remain the same, 0.05. So you may consider this or this. So as we have two tails, we have divided the alpha with 2. So we have the value for alpha by 2 is equal to 0.025. So we may consider this value. Now the question is that what will be the degree of freedom in this particular case? So as there are two populations, you will see the two samples definitely. So what will be the degree of freedom in this particular case? So degree of freedom in this case will be df is equal to nd. Basically the formula is n1 plus n2. So in this case there are two samples. One sample is nd, the other is na. And how many samples are there? There are two samples, so subtract 2. So if there were three samples, then you would have to subtract 3. So n1 plus n2 plus n3 minus 3. If there were 10 samples, so n1, n2, n3 up to and 10, and then minus 10. But normally we use up to 2 samples. So no problem, you may take this degree of freedom. So in this particular case, you have to see that what is nd and what is na. What is the sample size for the first sample, and what is the sample size for second sample? So 1, 2, 3, 4, 5, 6. 6 values are these, and 8 afternoon shifts. So 1, 2, 3, 4, 5, 6, 7, 8. 8 values are these and 6 these. So 6 plus 8. 6 plus 8 minus 2. 6 plus 8
12,
minus 2. What is the answer?
12.
12.
So 12 is your degree of freedom. Fine. So now you will come over here, and against this point 025, you will come down and see where is 12. This is 12. Move rightward. See the intersection. So this is the intersection point. 2.179. 2.179. 2.179 will be written here, and minus 2.179 will be written over here. Fine. So now you are familiar with the concept that this region is the rejection region. Similarly, this region is the region where you would reject the null hypothesis, and the region that comes in between minus 2.179 and positive 2.179. This region is the region where you will remain unable to uh, reject the null hypothesis, or the exception region. So this is the region where you would accept the null hypothesis, and these two regions are the regions where you would reject the null hypothesis. So now you may write down over here that if the critical value, if the calculated value, let me write down, if the calculated value of t statistic, definitely this is the value that you will calculate from the formula. If the calculated value of t statistic will be less than minus 2.179, or it will exceed positive 2.179, comma, we would reject H naught. So this is the decision rule that you would have to write down in step 4. And then you will move to step 5. So in step 5, there are certain calculations. So let us calculate things. So now you have to use SP square in the formula. So first of all, you have to find out SP square. So how will you find out SP square? For that, you have to use which formula? The first formula that I wrote over there. So you may write down again this formula first. T is equal to, so this is basically T calculated, XD minus XA. These are means, so put bar over there. Divided by SP square 1 over ND plus 1 over n a in this particular case. This is the formula that you will write down again. And then definitely as sp square is unknown, so write down what is sp square. So sp square is equal to nd minus 1 s1 square plus na minus 1 s2 square divided by degree of freedom nd plus na minus 2. Okay, so now you may see that to find out sp square, we have to find out s1 square and s2 square. So you will recall the formula for s1 square and s2 square. So you are familiar and you have used this formula several times. S1 square in this particular case will be definitely better would be if you write down, instead of writing S1 square, you may write down SD square, so that the idea is further clear. So write it down as SD square and S A square. So this is basically S1 and S2. Day is for shift, day shift, and A is for afternoon shift. So SD square, what will be the value for SD square? SD square. This will equal summation uh, xd minus xd bar whole square divided by nd minus 1. So its own degree of freedom. So this is the formula for SD square. Similarly, for SA square, the formula will be different, but simply up to notations. Sigma xa minus xd bar whole square divided by, so you have to take care of these braces, otherwise if you are not putting braces with the terms, then there will be problem. So here it is na minus 1. Fine. And there is no square root on these two terms because this is square. So when you will find out standard deviation, that is basically not required in this situation. We are interested in having SP square. So in SP square, variances are required, not standard deviations. So there's no need of putting square root on this to have SD. So as we are interested in finding out SD square and SA square, so there is no need of putting any square root on these terms. Okay, so first of all, you will find out xd bar, and then sorry, I have written it wrong. This is A, not D, because you are talking separately about the series. So this was for day shift, this was for afternoon shift. So A and A is there. So now but before that, as we normally use the manual procedure, so you must know that how will you solve the question manually on your answer sheet. So for that reason, I am solving it manually. So first of all, you will find out xd bar. So how will you find it out? You will add all those values that are there in day shift, and you will divide it with n d. So simply add the values. The values are, what are the values? 5 plus 8 plus so on up to the last value is 7. So add these values, 5 plus 8 plus 7 plus 6 plus 9 plus 7, divide by 6.
Seven answer.
Yes, Zoeb?
Seven.
Seven,
Exactly
sir.
7? Exactly
Yes,
7?
sir.
Fine.
Sir.
Yes, right.
So XD bar is 7. Now you are interested in finding out XA bar. So XA bar definitely summation XA divided by NA. So add the values that are there in the second series, and those are these values. 8 plus 10 plus 7 plus 11 plus 9 plus 12 plus 14 plus 9 divided by 8.
10.
8 plus 10 plus so on up to 9 divided by 8. The answer is
10.
10. So you have these two averages or means for the given samples. So now you have to write down two columns. Why two columns? Because you are interested in this term and in this term. So you will write down first column as xd minus xd bar. Okay, and then you have to take care of this. So takes another column xd minus x bar square. Then there will be another column for the other series xa minus xa bar, and then xa minus xa bar whole square, like this. So if you have values in front of you, if you have your book with you, you may give me the values. So the first value was 5, and the average is 7. Sorry, 7. The answer is 2. The next value is 8 minus 7, 1. So this is 4. This is 1. Move onward. 7 minus 7, 0, 0. 6 minus 7 is equal to minus 1, 1. Then 9 minus 7, 2, 4. Then 7 minus 7, 0, 0. I think there is something wrong. This is minus 2. So minus 2, 0, and plus 1, minus 1, 0. So now it is correct. The answer will be 0. If you will add the dispersion from mean, the answer will be 0. Fine. So you are interested basically in this sum of this. So 4 plus 1, 5, 6, 10. The answer is 10. The answer is 10. Now come to the next series. Write down the values. Uh, 8 minus 10 minus 2, 10 minus 10, 0. So this is 4. This is 0. Then 7 minus 10 minus 3, 9. 11 minus 10, 1, 1. 9 minus 10 minus 1, 1. Move onward. 12 minus 10, 2, 4. Then there is 14 minus 10, 4, 16. Then 9 minus 10 minus 1 and 1. So I think there is something minus 2, minus 3, minus 5, minus 6, minus 7, 6 and 7. So everything is correct, because in this case the sum will be 0, and in this case you may add. So if you have calculator, 13, 14, 15, 19, 19, 29, and 35, 36. Is it?
Yes, sir.
Yes,
I
sir.
have done verbally,
Yes,
not
sir. Yes,
not
sir.
calculator, so you have to confirm it.
Yes, sir.
Fine. So
Okay.
now you have this value and this value. And to find out SD square and SA square, you may substitute those values in the formula. So let us substitute. SD square is equal to 10 divided by 5. Definitely, and D minus 1. So 6 minus 1, 5. The answer is 2. SA square. And for this, you have to write down this sum, 36. 36 divided by 8 minus 1, because total observations were 8 in this particular case. So 36 divided by 7.
Sir, 5.14.
5.14. 5.14. Clear? So now you may find out the value for SP square, because the required S1 square and S2 square or SD square, SA square are there. So you have to substitute those values over here. Simply you will find out SP square. So what is SP square in this case? SP square and D minus 1. So 6 minus 1. What is S1 square? 2 plus next value NA minus 1. So that is 8 minus 1. Multiply by S2 square, and in this case SA square. So what was SA square? 5.14. 5.14. And divided with 6 plus 8 minus 2. So see what is the answer.
Sir, 27.24.
Sorry,
No, sir.
it will be 10 plus 5.14 multiplied by 7. Yes, Zohaib. What is the answer?
Sir, 27.99 हो रहा है.
7 multiplied by 5.14. The answer is 35.98. And now divided with 12. So plus 10, it is 45.98 divided by 12. The answer is
8312.
3.8316. So you may write it down up to
Sir, ये 6 minus 1 का सर ये 25 नहीं है ना सर.
this is
सर
not
ये
square of
25
this.
नहीं होना सर. ये 6 minus 1 का स्क्वायर.
No, it is not square. You have to multiply this with this. You have to multiply these
Okay.
two terms. This term is being multiplied in the formula. If you see the formula, it is S1 square. See the formula, multiplying. You are multiplying. So the value for SD square is 2. You have to multiply that value. So now SP square we have found, and now we can find out the T calculated. So X D bar minus XA bar divided by SP square into 1 over n d plus 1 over n a braces close square root. What is x d bar? 2. What is x a bar? 10. Sorry, x d bar is 7 and it is 10. 7 and 10. 7 and 10. 7 minus 10 divided by sp square 3.8317. 3.8317. 317. This is sp multiplied by 1 over 6 plus 1 over 8. This is close square root. Yes, who will solve it quickly? Minus 3 divided by.
Minus 2.8378.
Have you found the answer? Thank you very
Yes,
Minus
much.
sir.
2.8378.
2.8378.
7, 8.
78. But
2
sir,
point,
minus लगना है.
sorry, with
Minus
negative
में.
sign. Yes, fine. So this is the value, t value. Minus 2.8378. Okay, or you may write it down as you can see the table basically. So in the table there are values up to 3 decimal points. So you may write it down as it is equal to minus 2.838. Fine. So this is your calculated value, and definitely the same value will be there with positive sign because it is two-tail test. Okay, so let us consider this value. This is minus 2.838, and what was the critical value? Minus
179.
179.
2.179. So this was the critical value, or you may write it down as t tabulated, and this was t calculated. Fine. So which value is larger?
Minus 2.179.
Fine. So this value is larger. This is larger. This is larger. And what was the decision rule? What was the decision rule? The decision rule was if calculated value, yes, if calculated value of t statistic will be less than this, will be less than this. So what will you do? We would reject H naught. Less than this. Is it less than this? Yes, less than this. Calculated value is less than this. So what will you do? Reject
Reject.
H naught.
That's not.
Reject H naught.
Reject H naught. Fine. Clear?
Yes, sir.
So you may see that this value 2.838, if you want to see this value in the distribution, this value will be somewhere here. This is 2.1. So 2.838 may be at this point. At this particular point, it is 2.838. So it will be in the rejection region. So therefore, we are rejecting this value. Clear? So now come to the question. So we have basically solved it, and we should also write down the sixth step over here, that what this rejection means. So step 6 is interpretation. So interpretation of the result, how will you interpret this? You are going to reject H naught. So see, where is your null hypothesis? This is your null hypothesis. You are going to reject this. It means you are going to accept this. It means you are going to accept the alternate hypothesis, And what is there? Is there a difference in the mean number of defects per shift? So you will say yes, there is a difference in the mean number of defects per shift. Write down. Over here, based on the results, we may conclude that there are that there are or basically there is or there is difference in number of defects per shift, or better word will be in number of defects. There is difference in number of defects per shift, or you may write down between shifts. Okay, so basically we are not interested in knowing that in which shift more defects are there. Fine. If you are interested in knowing that in which shift more defects are there, you may have to reconstruct your null and alternate hypothesis. So we may also do that also, because if you see, we have found in afternoon shifts, in afternoon shift, on average 10 defects were there, and in day shift 7 defects are there on average. So you may rephrase, or there may be a question in this form instead of this statement. Is there a difference in mean number of defects per shift? The examiner may ask, is the number of defects in afternoon shift is the number of defects in afternoon shift more than the day shift, more than the day shift? So then you will write down the alternate hypothesis as mu A is greater than mu D. So if you are interested, I may solve that. Otherwise, if you can do that, then I will not go into that detail. So what is your opinion?
Sir, I think we can solve.
So all of you are able to solve this question in the other scenario. If it is
Yes, sir.
otherwise, if the question is there more defects in afternoon shift? Is there more defects in afternoon shift? So can you solve that question? Yes.
Yes, sir.
Fine. Very good. Very good. So in that case, there will be one tail. Okay. So we have solved this question, but let us see what is required over here in the parts. So if parts are there, then there is no need of writing down 6 steps. Then you will solve step by step. So state the null and alternate hypothesis. So we have done this. This was step 1, but you will write down part A, and answering that you will write down, you will construct the null and alternate hypothesis. What is the decision rule? So we have done this in step 4. So you will write down part B, solution and decision rule. What is the value of the t statistic? So we have done this in step 3. What is your decision regarding the null hypothesis? We have done this in last step, step 6. What is the p value? interpret the results. We have interpreted the results. What are the assumptions necessary for this test? So assumptions are these, that the populations are normal, both populations are normally distributed, and they are independent, and their means are equal. Okay, so these are the assumptions. So what is the p-value? This is the question that we have to find out. So for this, you will consider the calculated value of t statistic. The calculated value is 2.838. So you will locate this value against the degree of freedom. What was the degree of freedom? 12. 6 plus 8 minus 2. This was the degree of freedom. We have also find it out over here in step 4. Degree of freedom 12. Two samples are there. So against 12 degree of freedom, you will locate 2.838, the calculated value. And definitely you would have to consider the significance level. So what was the significance level? We have basically divided the significance level with 2 to have two tails. So 0.025. So let us see what is the value. This is the level of significance, 0.025. 12 is there. Move rightward. Locate 2.838. It is not there, but it is in between this value 2.681 and 3.055. 2.838 is in between these two values. So you will take this value into your account, and whatever significance level is given against this value, you will take that. So 2.681 against this, the level of significance is 0.01. So this is your probability value, 0.01. So come over here. What is the probability value? You will write down probability value is equal to 0.01. 0.01. So now you may compare it with the level of significance. So level of significance is 0.025, and this is the probability value. So which one is larger?
Point 0.025.
So
Yes,
this
yes.
is the rule that if probability
0.02.
value is less than alpha, if probability value is less than alpha, what we do? We reject H naught. Same result. So you may use any strategy. Fine. So now there are different questions, and you may solve all these questions. If you see any problem in any question, quickly have a glance. And if you feel any problem in any question, I can give you a hint how that will be solved. I think after solving this self-review, you are able to solve all these questions. So in some questions, let us say this question, question number 7 is there. So the required values are given in form of statement. So there is no need of any calculation. Simply write down the given values. For example, a random sample of 10 observations. So N1 is 10. Sample mean 23. So X1 bar is this. Standard deviation, sample standard deviation. So S1 is this. So you will have to take the square of this to find out, to write down the variance. Similarly, random sample of 8 observations means N2 is this. Sample mean X2 bar, fine. Sample standard deviation means S2 5. So S2 square will be 25. So level of significance also. So everything is there that may help you in finding out SP square, and then definitely T statistic will be used. As population standard deviations are unknown, but sample standard deviations are known. So everything is ready-made, everything is given. So there is no need of any calculation that we have done in self-review. But in these questions, you have to find out the values that are required to be substituted in T formula. So you may see this question. It is not that difficult, but what you have to do in this question: listed below are the 25 players on the opening day roster of the 2016 New York Yankees Major League Baseball team, their salaries and fielding positions. Fine. Sort the players into two groups: all pitchers and position players. Assume equal population standard deviations for the pitchers and the position players. Test the hypothesis that mean salaries of pitchers and position players are equal using zero point zero 0.01 significance level. So simply see, you have to separate, you have to write down a separate series for those where pitcher is written over there. So starting pitcher, you will generate a series for this. Okay, you will write down starting pitcher, whatever value is there, you write down that value onto that. Okay, starting pitcher. So wherever pitcher is there, you will write down one series for pitchers, and for remaining, you will write down another series. So definitely there will be two samples, one for pitchers and one for rest of the values, rest of the players. So you will sort the players into two groups, one for pitchers and one for the remaining. So in the remaining group, all those values where pitcher is not there will be written. And then the remaining question will be solved just like the self-review. Can you do it?
Yes, sir.
Fine. So other questions are very simple. There shouldn't be any problem. In question number 10, all values are given. You simply have to substitute the values in the formula to find out the t statistic. But in these two cases, data are given. So you will use data values to find out the required values that you will use in t statistic. Fine. So I'm sure that you can solve all these questions. And you have to take care of the tails in the distribution. So if the word differ or difference is there, I mean, if there is no interest of knowing that which average is more or less, so in that case, you will use the equality sign in the null hypothesis. And if you are interested in knowing that which out of two uh, population means is larger or smaller, then you would have to use single tail in the distribution. So accordingly, you will construct the null and alternate hypothesis. Okay, so you can also find out the same results using Excel. So I have written these values in the Excel. Okay, so let us find whether what we have done that is correct or not. So you will click data analysis. Here, t statistic, two sample assuming equal variances. So we have assumed equal variances of the population. So you will click this, okay, then you will click OK. And here you will give the range. How will you give the range? You will click this, and from here you will drag downward up to 7. This is your first series. Then second series, for this you will do in this way. Then you will click labels. It will be unclicked, but you have to click it. Why? Because the first row is representing the titles or labels. So therefore it should be clicked. And then what is the level of significance? It is same 0.05. Fine. And then you have to give the output range. So let us give the output range over here. This is the output range. Fine. And then click OK. So these are the results. Okay, so what is pool variance? SP square 3.833. We have done, we have found the same value. You may confirm it. And then degree of freedom is 12. We have found this. T stat minus 2.837. We have found this 2.837. This was the calculated. This was the calculated value 2.837. 2.838. It was basically 7, and I had rounded it off up to 3 decimal points. So therefore, this was the value. Clear? Then you can see the critical value 1.782, 1.782 for one tail. T critical one tail, T critical two tail. So basically this is P. P is the probability value. What is this? P is the probability value. So this value, if you see exactly, this is this value. Fine, 0.007. As I've said that I have taken this as this value 0.01. So we know that it is in between 0.01 and 0.005. So Excel is giving you the exact value. So the exact value is this value, exact value. Fine. And if you consider two tails, so then probability value will be this. So you can see that 0.007 in this particular case is less than 0.025 for one tail. So therefore you will reject H naught. Okay, similarly mean is 7. Afternoon, in case of afternoon, the mean is 10, variance 2 in first case, in second case it was 5.14. So everything, you can see that everything is there. Similarly, critical value for two tail 2.17. So if it was one tail, then you would have to have this value. But as we seen that there are two tails in the distribution, so 2.178 is there, and this is this value 2.178. So I have rounded off, so therefore it is 9. And basically, the software is giving you the exact value. So therefore 1.78 is there. So now I think everything is clear and we have done it correctly. So thank you very much for your patience, and meet you in the next class, inshallah, after the midterms. So wish you very good luck
Inshallah, sir.
with the midterm examination. Allah Hafiz.